All right, so we're still going to stick with simplifying rational expressions. You'll have an IXL assignment to do on that. It will be in 4, which is called Simplify Rational Expressions. But right now I want to do a couple more examples just to kind of cover all these cases that you might be struggling with, mostly because we still haven't mastered factoring. And that's why it's really the harder part of this, right? Is factoring, that first step, factoring the numerator and the denominator. So I think we've gotten pretty good at factoring trinomials, setting up our chart, but I want to do a little more with some binomials and pulling out the greatest common factor, which we did spend some time on in class, but um, it makes sense that you've maybe forgotten it because we haven't used it quite as much as factoring trinomials. So let's just do a quick example here. Number 1, we'll have 4z minus 12 over 8z plus 24. So notice these are binomials. These are not trinomials. And when I say that, I mean they each have 2 terms. There's 4z, and then there's this 12, there's this 8z, that's 24. So each, the numerator and the denominator, each only have 2 terms. So the first thing when we have a binomial is we want to look for a greatest common factor. What factor do they share? So let's start with the numerator. What can I pull out of 4z minus 12? Well, they both share a factor of 4, so I can pull out a 4. And I'm left with z, because when I divide 4z by 4, I just left with a z, minus 12. That 12 turns into a minus 3. So I've factored out z minus 3. Or sorry, I factored out a 4, and I'm left with z minus 3. Okay? Now I look to my denominator. What can I pull out of 8z plus 24? Well, I can definitely pull out an 8, right? They both have a factor of 8. So I can pull out 8, and I'm left with z plus 3. So 4z minus 3 over 8z plus 3. All right, because 24 divided by 8 is 3. Okay, so now I can simplify because really I have a fraction here. 4 over 8. And we know how to simplify fractions, right? They each are divisible by 2, so we can divide them both by 2. Where 4 divided by 2 is 2. Z minus 3. Sorry, my 2's and my z's are kind of looking the same. And then, oh, sorry. Wow, what am I doing? Ugh, worst teacher ever. Okay, sorry. They're both divisible by 4, more importantly. So they're both divisible by 2. I could have done that, 2, and it would have been 2 over 4. But they're both divisible by 4. 4 divided by 4 is 1. So on the top, I'll just be left with z minus 3. And then 8 is divisible by 4. And it's 2. Z plus 3. So what I really did was take 4 over 8 and rewrote this as 4 times 1. Rewrote this as 4 times 2. 4's cancel, and it simplifies to 1/2, which really we know that 4/8 is 1/2 because 4 is, well, half of 8. And I can't simplify this any more than that. Those z's don't cancel, those 3's don't cancel, 2 doesn't cancel with anything, obviously. So that's all I can do. Z minus 3 looks a lot like Z plus 3, but those don't cancel because they're not the same thing. Okay, now we want to set the original denominator equal to 0 and solve, so let's do that. Do that in this nice gold color. So our original denominator is right here. 8z plus 24 equals 0. So we want to solve. We'll subtract 24 from both sides. Cancels out on this side. And we've got 8 z is equal to negative 24. Then we'll need to divide by 8 on both sides to get the z by itself. And z is equal to negative 24 divided by 8 is negative 3. So that's our excluded value. So our answer, sort of in neat form here, is z minus 3 divided by 2 times z plus 3, where z cannot equal negative 3. And that's our final answer for that one. So notice I could have multiplied out the 2 on the bottom there. I could distribute that, but I don't need to. So I'm done. I'm fine leaving it factored. Okay, let's do. Oops, I'm doing all kind of crazy stuff here. I don't even know what I'm doing. All right, so let's. Accidentally uncircled that. We'll circle it again. Okay, let's do another example. So we'll go to a little lighter blue and do number 2. All right, so now I'm going to have 3x minus 3 over x squared minus x. Okay, so again, these are binomials, not trinomials. So my first thing is to look for a greatest common factor. That is what I always want to do first. GCF, GCF, that is the first thing when I'm thinking of factoring. Even, excuse me, even if I'm factoring things larger than binomials, if there's a GCF and you can pull it out, always do that. Because that's the first and easiest way to factor. And these both have greatest common factors. On the top, it's pretty obvious my greatest common factor is a 3. I pull out a 3, and I'm left with x minus 1, because I divide them both by 3. 3 divided by 3 is 1. On the bottom, it's a little less, maybe a little less obvious, but still not too hard to find. But they both have an x, right? X squared and minus x, they both have x's. So I can pull out an x. And here I'm left with x minus 1, right? Because if I take, just a side note here, if I take x squared and I divide it by x squared divided by x is, this is like x times x over x, and the x's cancel, and I'm left with x. So that's how I got that x right there. And then if I do x over x, then I've got, well, they cancel and then left with 1, and that's how I got that 1 right there. Because remember, when I'm pulling out this x right here, or this 3 right here, I'm just dividing. So I divided 3x by 3. I divided negative 3 by 3. So that's all I'm doing when I'm pulling out a GCF. Okay, so anyway, let's erase those last. Oops, who knows what's happening. Okay, goodness, I don't know what it's doing. I'm just trying to get rid of those marks so that you're not confused. But I'm clearly not very good at it. Okay. Sometimes I feel like an 80-year-old man trying to use technology. But I'm going to assume I'm better at it than most 80-year-old men. Okay, anyway. So our second step is to cancel out the common factors here. It's pretty obvious that x minus 1 is our common factor. Excuse me. So we're just left with 3 over x. And that's as simplified as we can get. So now we need to go back and set our original denominator equal to 0, which is kind of running out of colors, but that's okay. Right here, we want to set x squared minus x equal to 0. That's kind of hard to solve. So let's set the factored form equal to 0 instead. X times x minus 1. Now we know how to solve that. We set each factor equal to 0. So we set x equal to 0, and we set x minus 1 equal to 0. X is equal to 1, and x is equal to 0. So our final answer, all of that, is 3 divided by x, where x cannot equal 0 and it cannot equal 1. Because remember, if it's any of those excluded values, that would set the denominator equal to 0. And we can never have a denominator of 0 because we cannot divide by 0. So that's just a couple more examples using these binomials, factoring these binomials, canceling out. It's a skill you need to be good at and able to do. So this will apply to N4, which is your next assignment. And I'll be available to help you if you need help with that.